Hello. So we are now starting chapter 5, which talks about systems of linear equations and inequalities. So we're going to start with 5.1, which is the systems of linear equations in two variables. So all equations in the form ax plus by equals c are straight lines when graphed. We don't have or the exponent for x is 1, so it is a straight line. So two such equations are called a system of linear equations or a linear system. A solution to a system of linear equations in two variables is an ordered pair that satisfies both equations in the system. So a linear system that has at least one solution is called a consistent system. A linear system with no solution is called an inconsistent system. Okay, so let's look at determining whether an ordered pair or whether ordered pairs are solutions of a system. So we're going to start with this system right here, and we're going to determine if the ordered pair 1, 2 is a solution of the system. So what we are doing is we need to plug in the ordered pair 1, 2 to both equations. So we're going to start with equation 1, so the one that's on the top. 2x minus 3y equals -4, and plugging in 1, 2. The first one is x and the second one is y. So 2 times 1 minus 3 times 2 equals -4. So when we calculate the left side, we get -4, which equals -4. So this is correct. It is true. Now we need to check it in the second equation. So 2x plus y equals 4, the same ordered pair. 2 times x is 1 plus y is 2. And when we do the calculation on the left, we get 4 equals 4, which again is true. So we know now, because both are true, that 1, 2 is a solution of the system. Okay, let's look at the example, the next example here. So we have the exact same system. We just have a different ordered pair. So we're using 7, 6 now. We're going to start with the first equation. And again, plugging in the 7 as x and 6 as y. 2 times 7 minus 3 times 6 equals -4. So this is 14 minus 18, which is -4. So that is still true. So the ordered pair 7, 6 is the solution to the first equation. Now we're going to check the second equation. So 2 times 7 plus 6 equals 4. Well, that's 14 plus 6, which is 20. That is not 4. So this is false. So this means that 7, 6 is not a, a solution of the system. Okay, so next we're going to look at how to solve linear systems, and we're going to start by substitution. We're going to go over the steps on how to do this. So first one, we're going to solve either of the equations for one variable in terms of the other. So if one of the equations is already in this form, you can skip this step. Number 2 will be substitute the expression found in step 1 into the other equation. So this will result in an equation in one variable. Step number 3 is solve the equation containing one variable. And step number 4 is back substitute the value found in step 3 into one of the original equations. Simplify and find the value of the remaining variable. And then the almost the most important part is to check. And you always check the proposed solution in both of the system's given equations and in the original equations. All right, let's look at an example. So we have two equations here. We've got 3x plus 2y equals 4 is our first one, and the second one is 2x plus y equals 1. Now, we need to solve either of the equations for one variable in terms of the other. I'm looking at these two equations and I want to pick the one that has a coefficient of 1. So one that doesn't have a number in front of the variable. So looking at equation number 2, we have 2x plus y equals 1. Y, the coefficient is 1. Again, it is an understood one. It's not written there. So this one will be the easiest one. Otherwise, we're going to have to divide. So we're going to subtract 2x from both sides, and we get y equals negative 2x plus 1. So this is our step 1. Our step 2 is going to be substitute the expression from step 1 into the other equation. So now we're going to take our first equation, 3x plus 2, and we are substituting what we just got for y in step 1. So negative 2x plus 1 all inside parentheses, and that equals 4. That's all we do in step 2. Step 3 is going to be solving the equation. So we're going to go ahead and solve what we just got here. So we're going to start by distributing the 2, getting rid of the parentheses. So, oops, 2 times negative 2x is negative 4x. 2 times 1 is 2. So combining like terms, negative x plus 2 equals 4. Subtract 2, we get 2. And then divide by negative 1, we get x equals negative 2. So what we're going to do now is we're going to go ahead and back substitute this x equals negative 1 into one of the original equations. And I'm going to pick the equation 2 because it's easier without or with the y coefficient as 1. So our equation 2 is 2x plus, hold on a second, 2x plus, yeah, 2x plus y equals 1. I was going to write now I'm going to substitute. So 2 times negative 2 plus y equals 1. So we get negative 4 plus y equals 1. We add 4 to both sides. We get y equals 5. So we have the point negative 2 and 5 is our ordered pair. And now our step number 5 is to check. Make sure that you check by substituting into both original equations. But we know that negative 2, 5 is a solution of the system. Again, the checking is very important. Don't skip it. We know the answer is that, so we're gonna. Now, our next one is solving linear systems by addition. And I'm trying to figure out, there is another word that is used instead of the addition. Right now, I totally lost the word. But there's another one that is being used, which might be familiar to you, but it's the exact same. It's just a different name. So the steps for solving linear systems by addition are, so the first one is to rewrite both equations in the form ax plus by equals c. Step number two, if necessary, multiply either equation or both equations by appropriate non-zero numbers so that the sum of the x coefficients or the sum of the y coefficients is zero. Step number three is add the equations in step two. The sum is an equation in one variable. Four, solve the equation in one variable. Five, back substitute the value obtained in step four into either of the given equations and solve for the other variable. And then, of course, check the solution. Um, and again, this one, back substitute into the given original equations, or either of the original equations. Okay, so let's look at an example here again. We have elimination is the word um, that is used instead of the addition. So this can be by addition or elimination. That's another word that I've seen for this same method. It's the exact same method, it's just a different name. Okay, so we're going to rewrite both equations in the form ax plus by equals c. Well, if we look at our equations here, they both are already in that form. So we have equation 1 and equation 2. Next, if necessary, multiply either equation or both equations by appropriate numbers so that the sum of the x coefficients or the sum of the y coefficients is 0. Okay, if I look at these two here, we don't have, I mean, if we add 4x and 2x, it's going to be 6x. If we add 5y and negative 3y, it's going to be 2y. So neither one of them adds up to 0 right now. So what we need to do is we need to multiply one of these equations so that with the opposite sign. So looking at the 4x and the 2x, if we multiply 2x by 2, we get 4x. Well, it needs to be opposite, so we need to multiply it by negative 2 so that the 4x minus 4x cancels out. We get a 0. So for the first one, there is no change. For the second one, we are multiplying by negative 2, the whole thing. So what we end up with is going to be 4x plus 5y equals 3. That does not change. That's our first one. Our second one, we're multiplying by negative 2. So negative 2 times 2x is negative 4x. Negative 3y times negative 2 is negative 6y. And 7 times negative 2 is negative 14. We are adding these two in step 3. 4x and 4x cancel out. 5y minus 6y is negative y. Hold on a second. I didn't change. I need to change this sign. It is not a negative. Negative 3y times negative 2 is positive 6. So this should be 11y. And 3 minus 14 is negative 11. We divide by 11 both sides, and we get y equals negative 11. No, not negative 11. I am making mistakes. Y equals 1. That is our step 4. Step 5 is back substituting to find the other variable. So we need to find x. So I'm looking at the original here, and it really doesn't matter which original we take, 1 or 2. I'm just going to pick 1, which is the 4x plus 5y equals 3. We are substituting negative 1 where our y is. So we get 4x minus 5 equals 3. And now we're going to solve. So we're adding 5. We get 4x equals 8. Divide by 4 both sides. We get x equals 2. So we have 2, -1, and that is a solution of the system. Again, I skipped a step that you need to make sure that you do. It's to check that this is correct. All right, next we're going to look at the number of solutions to a system of two linear equations. So, and what this means graphically. So if we have exactly one ordered pair solution, that means that the two lines intersect at one point. So it looks something like this. That is our ordered pair right there. Okay, next one. If we have no solution, that means that the two lines are parallel. So it looks, for example, there's one line and there's the second line. They are parallel. They never cross. So there is no solution. The third option is infinitely many solutions. And that means that the two lines are identical. So when we graph the two lines, it looks like this. They're on top of each other. They're exactly the same. Okay, let's look at this next example. So we are supposed to solve the system. We have 5x minus 2y equals 4 and negative 10x plus 4y equals 7. I'm looking at this and I'm going to use the addition because it's if we start substituting, so we would need to solve for 1, we would have fractions here. If I multiply this top equation by 2, I get 10x minus 4y equals 8. So as you can see when I'm writing the second one, this will cancel the variable out. Well, 10x minus 10x is 0x. Negative 4y plus 4y is a 0y also. 8 plus 7 is 15. So we have 0 equals 15. Well, this is false. 0 does not equal 15, right? So what this means is that the system has no solution. And now going way back to our first page here, a linear system with no solution is called inconsistent system. So it has no solution and is inconsistent. Another way of saying that it has no solution is that the solution set is empty And the way we can write an empty set is braces with nothing in it. If you put 0 on here, it means that there's a 0 in the solution set. So it has to be completely empty. The other way is to do a 0 with a line above it. This is also a symbol for an empty set. So this was a system with no solution. Okay, next we're going to look at a system with infinitely many solutions. So we're going to look at what does it actually look like. Now, looking at these equations, our equation 1 is already, it's in the form x equals. So what I'm going to do is I'm going to substitute. So I'm using substitution here. Substituting equation 1, so x into equation 2. So we've got 5 times, and instead of x, I'm writing 4y minus 8 minus 20y equals negative 40. Okay, now we're distributing. So 20y minus 40 minus 20y equals negative 40. Well, 20y minus 20y is a 0. So they cancel each other out, and we get negative 40 equals negative 40. So this is true. This means that the system has infinitely many solutions. And is consistent. It has at least one, so it is consistent. Now, the way we can write this in a set is we would do braces so that it is a set and put xy is such that x equals 4y minus 8. So that is this one right here. Or we can do xy is such that and write the one that is, or the second equation here. Either way is a correct way of writing that this system has infinitely many solutions. Okay, next thing that we're going to look at is an application here. So we have a company produces and sells X units of a product. We have a revenue function, R of X equals price per unit sold times X. And we have the cost function, C of X equals fixed cost plus cost per unit produced times X. The point of intersection of the graphs of the revenue and cost functions is called the break-even point. So our example is to find the break-even point. We have a company that manufactures running shoes, has a fixed cost of $300,000. Additionally, it costs $30 to produce each pair of shoes. They are sold at $80 per pair. So we're going to write the cost function. So a fixed cost, C of X. A fixed cost is the $300,000. Oops. Right here, plus cost per unit produced times X. So $30 times X. Now, our revenue function is price per unit sold times X. They are sold at $80 per pair, so our R of X is going to be 80 times X. Now we need to determine the break-even point and describe what it means. So we're going to do a system of equations here. We're going to write the cost function, 300,000 plus 30x And then the revenue function, y equals 80x. We have a system of two linear equations right now. So what we're going to do is we have a y and a y, so we can actually set these to equal. So we can do 300,000 plus 30x equals 80x. And now we're going to move the 30x to the right side. We get 300,000 equals 50x. We're dividing by 50 both sides, and we get 6,000 equals x. Okay, we found our x. Now we're going to go ahead and substitute this into the revenue equation to find y. So y equals 80 times 60,000. So I took this revenue function here. And now 80 times 60,000 is going to be 48,000. So what does this mean? It means that our the break even point is 6,000. Hold on, I'm missing a zero here. It should be 480,000. 480,000 right here. So what does this mean? That's our break-even point. The company will break even if they sell 6,000 pairs of shoes at this level. The money coming in is equal to the money going out, $480,000. Okay, that's it for lesson 5.1. Let me know if you've got any questions. Bye.